Interview season is on the way, guys, and I'm sure many of you want to change your job in AI. If yes, don't miss this video and thank me later. I'm gonna cover 20 very critical AI concepts that your interviewer is going to touch in your next AI interview. So guys, let's start this very important video. And what I thought is I will present this to you in the form of a framework. What is my framework? My framework is very simple. I'll first of all give you an overview of what that concept is or what that topic is. For example, if I'm talking about RAG, then what is RAG and why it matters? Okay. Then second thing that you should understand, which I just said, why it matters, why you should know about this and why you should expect questions around this in your next interview. Then very important, I have created an architecture diagram for you. By looking at that, you will understand this concept fully. Okay, so architecture. And next, what I'm going to cover is I'm going to cover the key concepts in that area. So what is the meaning of key concepts? If we take RAG as an example, then people might touch you. What is RAG 2.0? What do you understand by chunking? What do you understand by hybrid search, etc.? So what are the key concepts in that area? And then we are going to see the interview questions and some of the summary of that topic. Okay, key concepts, and after that probable interview question in that area and a summary which you should remember, so that you know that's like one liner or two liner summary of that particular question. So interview questions and summary. I am also going to give you some YouTube video link if you want to understand these topics in detail. So this will be the framework we will follow. Now the thing is how to present this framework to you. What I have done is I have created a nice website. Website means it's a simple web page where for every topic I have an overview, I have why it matters, I have the architecture, I have the key concepts, and I have interview question and summary. What we will do is we will just go through this for 20 important AI topics or concepts. When I say concepts, it will be a broad area. Okay, in that area what is important. For example, what you can see on the screen is 20 AI concepts in the form of a web page. Don't worry, I'll share this project with you. But first of all, let me walk you through this project and the important concepts. So if you see this RAG 2.0 page, it follows overview, why it matters, architecture, key concepts, and then interview questions. And then real world application is another thing you can see, summary and some videos which you can watch. Let's start guys on this framework. First of all, RAG, critical one. If you go for any interview, they might ask you RAG related things. What is RAG 2.0 or advanced RAG? RAG 2.0 enhances traditional retrieval augmented generation with multi-stage pipelines. Okay, what happens in those pipelines? In those pipelines we have hybrid search, re-ranking and adaptive query strategies. It addresses hallucinations and context limitation by dynamically retrieving and synthesizing information from multiple sources. So this is different than RAG 1.0. RAG 1.0 was all about keeping a knowledge base, fetching the information. This does many additional things. Why it matters? This is essential for enterprise AI system requiring accurate and traceable responses. 1. This overcomes knowledge cutoff and hallucination. Industry standard used by Perplexity, Bloomberg, etc. and critical topic for LLM application discussions. That is why it is number 1 in our list as well. Now see this architecture carefully guys. This is the main thing. If it's a traditional RAG, right, what you will see is you will see a query here, you will see a knowledge base here, and you will see a LLM here and the response. That's it. But it's not a traditional RAG, it's a RAG 2.0. User query will come and it will get rewritten. What is query rewriting? See here, rewriting, query rewriting. User queries may not match document language. Generating multiple query variations increases recall and catches different phrasing. For example, ML models can be rephrased as machine learning model or ML algorithm, neural network, etc. So this is your query rewriting part. Basically, user query will be written in different ways. Then the concept of hybrid retrieval has come into picture. What is hybrid retrieval? A mix of dense search, which means semantic search, and sparse search, which means keyword search. If you mix these two searches, right, it does a different type of job altogether, because both these searches are for different purposes. So till here you are not hitting your knowledge base in the full way. You are simply doing a query rewriting and you are doing a dense search and sparse search. Here you are hitting your knowledge base, but not like you do in traditional RAG. Then you get candidate chunks. Then you do a re-ranking. Re-ranking means suppose you get chunk 1, 2, 3, 4, 5. You see which one is more relevant and you bring that on the top. Then you do context compression because you want your LLM to be efficient. And then you do generation, and then you do the response and citation. So this is RAG 2.0. This is not a traditional RAG. What are the key concepts in RAG? As I was telling you, traditional RAG uses single vector search. RAG 2.0 adds query rewriting, hybrid search, ranking, compressing, generation stages. What is hybrid search? One search will be semantic, one search will be keyword. Queries often need both semantic understanding and exact meaning. Fusion method will be used or weighted combination will be used. I am giving you very high level view of what is RAG, how it works, what are the new things you should know. The idea is very simple. When interviewer brings you, what do you mean by hybrid search in RAG? You should not say that I have no idea on this. After this video, you are having idea. Okay. What is re-ranking? Basically, bringing the more relevant results on the top. What is context compression? You can read all these later, but I am just giving you a gist, okay? Retrieved chunks may contain irrelevant information. Whatever is more relevant for you, you bring that. Basically, you make your context in such a way that it is more relevant for LLM. What is query rewriting? We already saw an example. User query will be written in multiple ways. What is self-RAG and adaptive RAG? Self-RAG is LLM decides when to retrieve and how to use retrieved info. Adaptive RAG route simple queries to LLM, complex ones to retrieval. This is also one interview question. Okay. And then I have given you some interview questions here which you can go through yourself. And in the end, the summary RAG 2.0 is equal to multi-query retrieval, hybrid search, re-ranking, context compression, cited generation. Along with this, I have given you some video links which you can go and see. Now these are two of the live videos I did very recently on LLM engineering. And here I am building a complete full-fledged RAG. Go and watch, that is RAG 2.0 only. If you are watching this video on before 14th of December 2025, then on 14th of December we have the third part of this live on YouTube. You can join that. Okay, but first watch these two. So if you go through this page and if you understand the architecture, if you understand key things, then I'm sure many of the RAG questions you can answer in the interview. Or at least you will have some idea and then you can build on top of that. This is our first topic in this. Now let's go to the next topic, and that is AI agents and tools. This is one topic that interviewer love to touch. What is AI agents and tool? So first of all, let's see architecture only. What is AI agents? In agentic AI, it will always be a goal. LLM will be a reasoner, which will decide, which will plan, which will do the tool selection, and which will do the reflection, right? Basically, LLM will think how to do the work. Then there will be a tool registry where multiple tools will be there: API calls, code execution, database queries, web search, etc. Then there will be tool execution in an external environment outside of agent. Then there will be observation. Observation means result of the tool. And then LLM will do the reflection. Reflection means goal achieved or not achieved. Remember, here we are talking about AI agents and tool use. The third topic is function calling and structured output. Both are different and it's a very common interview question. What is the difference between AI agent tools and function calling? Okay. So why AI agents and tools use matter? AI agents are autonomous systems that use LLM as a reasoning engine to plan. So basically, LLM plans how to perform a task and it has tools and it has different things which it can use. Why it matters? This is the age of agentic AI, as you know. Building practical AI application, enable AI to take action, used by LangChain, AutoGPT, etc. And core topic for AI system design discussions. That is why AI agents are critical. This is a high level architecture. You see this from the user goal. to LLM, to tool registry, to execution, to observation, to reflection. I told you this is a very important concept. What is the difference between agent and function calling? Understand this, guys. Function calling is a single turn LLM function response model. This is our third thing here, okay? Agents use multi-turn loops: plan, act, observe, reflect, repeat. So if you come here, right, planning, then acting, then observation, then again see goal achieved or not, and then again it will plan and again it will act. That is your agent. But your function calling is basically LLM function and response, single turn. Okay. The key difference is agent autonomously plan multi-step workflows, whereas this is a single turn and agent is a multi-turn. What is a react pattern? Reasoning and action. So agent will do the reasoning, how to do this, and then act on behalf. For example, thought, action, observation, thought. This pattern it will follow. Tool selection and execution. Agent maintain a tool registry with available tools and descriptions. For example, in this tool registry, we have lot of tools which agent can use. Whichever tool agent thinks is good to use, agent will go and use that tool. That is your tool selection. What is planning strategy? Different strategy. For example, plan and solve, react, reflection, and multi-agent. Then you can prevent infinite loops by doing few things. For example, implement timeout, detect repeated tool calls, or circular reasoning. So people will ask you in interview, how do you overcome the infinite loop problem in agent? So the answer to that is this: detect repeated tools or circular reason, or provide feedback mechanism to return partial results if stuck. Then there are interview questions you can see. Real world application, LangChain agents, AutoGPT, Microsoft Copilot, research assistants. I am sure you have used many of this. Summary is agent is equal to LLM reasoning engine plus tool selection plus execution loop plus reflection until goal achieved. I am linking two things here. One is my YouTube video here, which is on agents. You can go and see. And second is my Udemy course on agentic AI for beginner, which also you can go and see. So if I open this link, right, second one, this is my Udemy course on agentic AI for beginner. If you are a beginner in agentic AI, you can just do this. As you can see, around 4.4 rating, 1400 people have rated, nearly 7200 people have taken the course. It's just 4-hour course. You can go to Udemy and do it. It will help you a lot if you want to know how agent works in real world from the scratch. Okay. So this was about links where you can go and gain more knowledge, but these are the areas which in agentic AI your interviewer might touch. What is the next thing? Next thing is function calling and structured output. So it is not very different from AI agents. You have to understand just one thing. It's a one turn, single turn. So agent is given, LLM is given some functions which it can invoke. Simple. So why it matters? It is deterministic and persuasive outputs. It bridges gap between LLM and existing systems, schema validation, etc. And user query will come. If you see the architecture, right? User query will come, LLM will be there. Diffusion call function or respond directly. If function, then it will call the function. It will validate the schema. It will execute the function and return result to the LLM. LLM generates final answer. So if you see here, it is following a pattern, a schema, calling the function, getting the answer. That's it. Simpler than agent. Okay. What are the key concepts? LLM generate free text which is hard to parse reliably. Okay. Function calling solves this by having the LLM generate structured JSON function calls. So there will be a structured JSON which will be used here. Outputs will also be structured. There could be parallel function calling. There is a concept of schema design, meaning clear function and parameter description guide the LLM. So, for example, mark required versus optional parameter use enums for constraint choice. For example, temperature units, and support nested operation for complex structure. So basically it is following a schema design. Error handling can be done. This is not very different from agent. Only one difference, it is following a schema and it is a one-time call. So you can read the interview questions, you can see the real world application, and you can come to summary and you can read the summary as well. Basically, LLM generates structured JSON function invocation instead of free text, enabling deterministic API integration. So if you want to integrate APIs, this is a nice path to go. I don't have a dedicated video on this, so I have written NA. Now the next topic is very interesting, guys. This is called multi-vector embedding. So what is multi-vector embedding in very simple understanding is, imagine there is a document. Now this document will be converted into chunks, and the same document it will be converted into summary, and the same document it will be converted into metadata. Imagine there is one PDF file. You create three things from that PDF file: chunks, summary, and metadata. You create one vector from this, you create one vector from this, and you create one vector from this. Vector means embedding basically. And then you do multi-vector index. Then you create your query vector, and then you do multi-vector retrieval. You do a fusion of this basically. You mix all these things together. Now, what do you think is the advantage of this? Pause this video for a moment and let me know what is the advantage of, if there is a PDF file, why I will want to create chunks also, summary also, and metadata also. Just tell me in comment. Take a pause and tell me in comment. Okay. If you are not able to think, basically all these solve different purposes. Chunks will give you basically bits of information clubbed together. Summary will give you a high level overall view of the document, and metadata will give you metadata information that you should have. And when you combine all these things together, right, then you can do a better search and retrieval. And the same thing which I discussed now, if you see here, right, multi-vector embeddings represent documents multiple vector instead of one. Different semantic aspects it capture document structure and multiple semantic facets. Used by Pinecone, VB, etc. Single vector loose granularity for complex document. Common topic in RAG and retrieval system discussion. All these things you have to use in interview. Okay. Key concepts. As we were telling, single vector can't pull all semantic facets. Chunk level. Each document chunk gets in on vector. Summary. Document summary vector. Metadata. Embed structured metadata. And hybrid. Combine all three. Then retrieval fusion. The technique. How do you fuse all these things together? So there is a concept called reciprocal rank fusion. Then chunk size trade-off. What is the chunk size you want to have? Typically 200 to 500 tokens per chunk is recommended with 50 to 100 tokens overlap. Contextual embedding. Static embeddings are fixed. Contextual embedding adapt to query, providing better semantic matching. So basically we will create contextual embedding. What are the interview questions that can come from multi-vector embedding? Here I have listed some. What are some of the real world application? Again listed some. And summary is here. Multi-vector embedding is equal to multiple vectors per document. Chunk, summary, metadata for richer and more granular retrieval. Understood? An example you can see here. See example here. Embed structured metadata. Author date category comes in the metadata. Document summary vector. Coarse grain, good for overview queries. Chunk level. Each document gets in on vector. Fine grained. So chunk is normal. We do chunking always. But summary level and metadata is new. And then hybrid means you combine all these things together. Okay. This topic, very high possibility interviewer might want to touch. Diffusion models. Again, let's see the architecture first. What is a diffusion model is basically, imagine there is a real image and you keep adding noise in that image. Plus noise, plus noise, plus noise. And then what you get is pure noise. Okay. And then in the reversal process, what you are doing is you are doing a generation of the original image. So this is the real image from where we started. We added noise, and finally we got pure noise. In the reverse process, generation process, we start from pure noise, we denoise, and finally generate the image. And this happens using UNet. Okay, UNet is a basically encoding technique. We will see that. Forward pass, this is the training pass. And what is the text conditioning? Basically text prompt you will take, you will do text encoder, then cross attention you will apply, and UNet through image. So this is another associated concept. Okay. So what is diffusion models? Diffusion models generate data by iteratively denoising random noise, like the way we saw here. Okay. And then what it can do is, when the model is trained, it can generate very nice images. So there is forward and reverse process. This is your forward process and this is your reverse process. U-net architecture, U-shaped encoder decoder architecture with skip connections. So this is a different kinds of architecture used for this kind of model. Okay. Latent diffusion is concept related to diffusion model operating in pixel space in slow and memory intensive use. And then conditioning and guidelines, text conditioning, clip encode text, cross attention guides generation, classifier free guidance control, how closely model follows the prompt. So different tuning, basically different what you say ways to make your model better. Sampling method basically is DDPM, uses stochastic sampling. And here are the interview questions on this topic that you can read. But what are the real world applications of this? Stable diffusion, I am sure many of you would have used. DALE E2, I have created video on this. Mid Journey also, I am sure many of you have used. Runway Gen 2, Sora, these are famous applications in this. Okay. Diffusion models is equal to iterative denoising from noise to data, learning the reverse of a forward noise adding process. Remember, these are the topics that can be touched in the interview. So you can read about these topics a little bit more. But if you read this sentence or this paragraph also, you are better than I don't know. Okay. Now let's see the next one, which is called vision language models. What are vision language models? Let's see the architecture only and we will understand. So it is a mix of image and text. So what is happening here is, there is an image, there will be a vision encoder such as VIT or CNN. It will create image embeddings. Then there will be a text, it will basically be text encoding, and then text embedding and image embedding both will basically mix through a cross attention, and there will be a fused representation, and this fused representation will be used for purposes. What is the meaning and what is the example? Vision encoder, if you see your overview, right, vision language models process and understand both image and text simultaneously. If you remember, you give some image to ChatGPT and it gives you answers, right, or some video. That is your vision language models kind of methodology, enabling tasks like image captioning, visual question answering, and multimodal reasoning. So how it works or why it matters? Foundation for understanding visual and textual information together. GPT-4V, Cloud 3, Gemini Pro Vision are the examples for this. What will be the application? Autonomous vehicles, medical imaging, content moderation. Critical topic for multimodal AI. You know, this is a hot topic in the world of AI, right? What are the key concepts? Vision encoder or vision transformer, VIT, divides images into patches and processes it like tokens. CNN uses traditional convolution approach. Output is image embedding feature. VIT is better for large scale, CNN for efficiency. So this is again an interview thing. Cross modal attention, purpose is to fuse vision and language information. If you see here, right, this is language information and this is vision information. The purpose is to fuse both these things, and then you get a fused representation. What are the fusion strategies that is used? Early fusion concatenates image text feature early. Late fusion use separate encoders. Hybrid uses multiple fusion points. Late fusion better for complex tasks. So multiple fusion methodology is here. Task and application, as we discussed, image captioning, visual QA, visual reasoning, multimodal review. And training approaches, contrastive learning, CLIP style, uses image text pair, generative BLIP style, or instruction training, LLAVA style. Choice depend on target tasks. If you want, explore these, but just know these are different training approaches in vision language models. Some interview questions here, which you can read. Real world application, as we saw all these names on the top, and Google Lens, medical imaging, etc. Summary, vision encoder plus text encoder plus cross modal attention, unified understanding of image and language. Just keep this in your mind. Anyone tells vision language model, keep this in your mind. Okay. Next, go to LoRa, QLoRa, and DORA. Very simple to understand this one. This is about fine tuning your model. So suppose this is your original weight of the model, original basically LLM, the large LLM, and this is your LoRa decomposition. So you create a new matrix. That matrix is B cross A, and then in place of retraining all the weights in W, you train B and A only. So this is your B trainable and A is trainable. So in place of training large model, you train a small matrix just to save time, hardware and all those resources, right? And then you get the fine-tuned model. What is the key concept here? Parameter efficient fine-tuning methods that adapt large language models with minimal trainable parameter. I have created detailed video on this topic, guys, and I have given you the link here. Okay, if you want to learn more on this topic, please go through these videos and you will learn a lot. Okay, and what are the topics for this? What are the ways to do this? Low rank adapters, QLoRa adds quantization and DORA improves weight decomposition. So there are three variants. Why it matters? Fine-tune large language models, train less than 1% of parameters normally. Used for instruction tuning and essential topic for model adaptation discussions. So what is the LoRa basic? You simply create a smaller weight matrix and you train this metric. What is a rank parameter? Rank parameter is an internal parameter that you use inside your LoRa. So better expressiveness, it tells you lower R is equal to fewer parameters, faster training. So you can choose the R. There is a formula also of choosing R. I have discussed in that YouTube video. QLoRa, what is that? This uses something known as quantization. What is quantization? Quantization is a way to make your model smaller. So you can read about it. What is DORA? DORA is LoRa only adapts direction, not magnitude. Solution: decompose weights into magnitude and direction. Mechanism: apply LoRa to direction, learn magnitude separately. So a new approach of fine tuning DORA. Then adapter placement is one concept in this. Attention layer, this is most effective. MLP layers add capacity but with diminishing return. All layers provide maximum capacity but more parameter. Typical attention layer only for efficiency. So basically which layer you want to pay more focus to. You can read some interview questions here, and as I said, you can watch these YouTube videos, and this is the summary. LoRa, low rank adapters added to frozen weights. QLoRa adds 4-bit quantization and DORA improves weight decomposition. Let's move to the next topic, and this is one of my favorite topic, model distillation. Basically from a large model, you create a little less powerful model, but you do it with very smart method. Okay. So what you do is you take a training model which is large and frozen, and here are the soft targets for that model on some data point. Then you take a small student model, small model, and then what you optimize for is the combined loss, distillation plus task loss, and then you train the student model. On this topic also I have a detailed video. Here is the link. You can go and watch the detailed video on how this knowledge distillation works. Okay, but at a very high level, you are taking a large model, you are calling that teacher. You are creating a small model, you are calling that student. What is the benefit? The benefit is enable AI on mobile devices, smaller models, critical for real-time application, common topic in model optimization discussions. Then soft versus hard targets. Hard levels are 100, soft will give you probabilities. Temperature scaling, how much you want to soften the probability in your formula. Again, these things I've explained in my YouTube detailed video. Loss function also, KL divergence loss is what you use, explained in that video. Knowledge transfer means transferring the learning from the previous model. Compression ratio, how much you want to compress. Performance, 80 to 95% of teacher performance. Trade-off obviously will be there, size versus accuracy. Examples is distill BERT and tiny BERT. You can use these models and see. Interview questions and summary to remember. A student learns from teacher's soft probability distribution, not just hard levels, enabling smaller models with preserved performance. Please watch this video. I am not saying this on all the things, but this video is very important for you if you want to know model distillation. Okay, please learn that. Quantization. If you remember, we discussed quantization in this LoRa, QLoRa and DORA topic, but this is again making a model small to work with. Okay, quantization reduces model precision from 32-bit floors to lower bits. So what happens is dramatically reducing memory and accelerating inference. So I want to make a model more usable, so light, and that happens when I reduce the model precision from 32 bits to 4 or 8 bits. What is the architecture? 32 bits weights or whatever you call it, model parameters will be here. Quantization will scale it, or it can be 0 point, or it can be round and clamp. Then you go to INT8, INT4 way. Then if you want, you can do dequantization for computation, and then FP32 output you will get. Okay, so this method is used to make your model small and more usable. Key concepts, you can read about F32 weights and symmetric and asymmetric way, pre-tensor versus per channel quantization. Calibration is purpose to determine optimal scale and 0 point. Quantization method is post training or quantization aware, and these things are basically, if somebody wants to go into these topics deeper, they will ask you these topics. Okay, some interview questions I have given, just read it. Quantization converts FP32 weights activation to INT8, INT4 using scale and 0 point or any other method, reducing memory and accelerating inference. Watch this video, very important video if you want to understand quantization. Okay, and then the prompt optimization. What is prompt optimization? So there are only 3 ways in which you can use a base LLM in your company or in your business. One is by writing better prompts, that is prompt engineering. Second is RAGs, and third is agents kind of thing, right? So what is that you want to do? Here we are discussing prompt optimization, or in other way prompt engineering. So prompt optimization techniques structure LLM inputs to improve reasoning accuracy and task performance. So there are different ways in which you write the prompt. For example, this is chain of thought flow. You give the problem, then step 1, step 2, step 3 happens, and then answer comes. React flow, in which problem, thought, action, observation, thought, action, observation, answer. And tree of thought, problem, their LLM will show different paths or evaluate different paths of solution. Evaluate it, then go to one path and find the answer. So this is about your prompt optimization. Why it matters? Improve performance, better results used in production AI system. Critical topic for LLM application discussions. Again, chain of thoughts, react pattern, tree of thoughts we saw already. Self consistency, generate multiple COT paths. Few short learning is you give some examples to the model. I am running very fast. The reason for that is, guys, I'm saying these are topics, but these are not topics. These are group of topics under all these numbers. Okay, so what all they can touch and what you should know, I'm giving. Many of these you know, but if you don't know, you can, I'm giving you a video link also here, right? You can see the details, or you can do some googling and learn about that. But if you are not prepared on these areas, right, you might not have a very comfortable time in the interview now. Okay, few short learning is basically giving examples, making your model learn from those examples. Here are some interview questions, and here is the real world example: LangChain React, Auto GPT, Wolfram Alpha integration. You can try this, very nice for mathematical reasoning, and research assistance for chain of thought. Okay, so what is prompt optimization? Structured prompt with explicit reasoning, tool use or multiple paths to improve LLM performance. Now what I'm going to do is, I'm going to take a pause here, and I'm going to cover the next 10 in the part 2 of this video, because I don't want to give you a lot of information, number one. Number two, it might be overloaded for some people, seeing lot of new terms, but everything is not new. Okay, if you are into generative AI, then you would have heard about LoRa, QLoRa and DORA. What I'm doing, I'm just giving you at one place all the concepts, so that you know, okay, in this topic this is also there, okay, in this topic this is also there, okay, here are the things that they can ask, here are the things they can ask, and if you want to do a quick revision, here are the videos. That is what my purpose, guys. Give me a comment that you are excited for the part 2 and you want this in Git. So what I will do is, I will just put a GitHub repository for this, and I will share that with you, so that you can directly see in the GitHub all these things. Okay, and whatever you liked or whatever you want me to cover more, drop me in comment. Till then, wait for the part 2, guys, and your comments and motivations are always important for me. Please keep giving that. Thanks all, see you in the next part.